This is the graph of y is equal to the modulus of 2x minus 4. We can write down the equation of this line separately to this line, like this. This is a different modulus function. Y is equal to the modulus of x minus 4. And as before, we can write down the equations of each of these two lines separately. Y is equal to x minus 4. Y is equal to minus x plus 4. Now we're going to put both modulus graphs together. There are 2 points of intersection between these modulus functions, and this one here has an x coordinate of 0. That's obvious from the graph. If you had to work it out using a bit of algebra, it's this line with the equation y equals minus x plus 4 that intersects with this line that has the equation y equals minus 2x plus 4. So solving them simultaneously, so minus x plus 4 is equal to minus 2x plus 4. If I add 2x to both sides, then I get x plus 4 is equal to 4, and subtracting 4 from each side, x is equal to 0, which is something that we already know from the graph. To work out the x coordinate for this point, we take the equation of this line, y is equal to minus x plus 4, and we take the equation of this line and we solve them, y equals 2x minus 4. Adding x to both sides, adding 4 to both sides. So the x coordinate here is 8 over 3. Let's say that we're trying to solve this inequality. The modulus of 2x minus 4 should be greater than the modulus of x minus 4. So when you're looking at the graph of this modulus function should be higher than, should have y values greater than this modulus function. So looking at the graph here, for this region, we can clearly see that this blue graph is above the red one. The blue one is more than the red one. For values of x which are less than 0, so when x values are less than 0 in this direction, this graph is above this one. This one is more than, it's above this one. This is also true for this region of the graph as well, where once again the modulus of 2x minus 4 is above the graph of the modulus of x minus 4. So for values of x which are more than 8 over 3. Instead of sketching graphs and then working out the points of intersection between the two modulus functions and then solving inequalities, which is quite a long process, we can use an algebraic method without sketching graphs, and we will come to the same solutions. The modulus means that nothing can be negative, and the same thing is true if you square something. So if we start off by squaring both sides, so I'm removing the modulus function here and replacing each side being squared. I've now moved the x minus 4 squared term to the left hand side, so I've subtracted this term from both sides. So now we have this. Now you may recognize that this is simply the difference of two squares. So you've got a term here, everything there in the brackets is squared, and you have another term here and everything in brackets here is squared, and you've got that difference in between. So essentially you've got something that looks like this: one term squared, minus another term squared. And you know from your work in AS that the difference of two squares can be factorized to give you the sum of A and B, so the sum of these terms and these terms multiplied by their difference. So if you take these terms and from them you subtract away these terms. So applying this result to what we have here, well, you need brackets. That says greater than 0, so we're going to end up with something like this. So inside here, we're going to add the terms together. So whatever you see here and here, add them together. So 2x plus x gives you 3x. The minus 4 plus minus 4 will give you minus 8. And in here, we're going to subtract. So it's these terms here minus these terms. 2x minus x will give you x. Minus 4 minus minus 4. Okay, listen carefully to the signs here. That number is a minus 4, that number is a minus 4, and we're going to subtract. So minus 4 minus minus 4, which essentially is minus 4 plus 4, which gives you 0. So I could do this, plus 0, but there's a little point in putting plus 0 in this. So this is the inequality, all factorized, that we now need to solve. So the critical values that we get from this, x equals 0, and from this side, if you write 3x minus 8 equals 0, then x is equal to 8 over 3. And then using the method from AS maths for solving inequalities, x times 3x is 3x squared. That's a positive coefficient of the squared term, U-shaped curve. And we have 0 and 8 over 3, so on the number line 0 is on the left and 8 over 3 is on the right. Greater than 0 means the region above this line, so x is less than 0 and x is greater than 8 over 3. Okay, so the graph is above the line here for values of x which are less than 0, and the graph is above this line here for values of x more than 8 over 3. So these are the solutions, but without doing sketches for the modulus function graphs. And you have the same solutions that we had before here, but without having to do all of this. It's worth having a look at why in this step I used the difference of two squares instead of expanding the brackets, grouping like terms and then factorizing. Okay, so let's take this step here and try an alternative method forwards. So instead of using the difference of two squares, I'm now going to expand brackets and then simplify, and so on. Okay, so let's expand the brackets for each of these. So expanding the brackets gives these terms, and then simplifying gives these. It's at this stage that if you end up with a 3-term quadratic, you could be wasting time trying to factorize that, where it would be easier to use the difference of two squares and avoid having to factorize, like you are here. This is an easier example, but if you had a 3-term quadratic, so if you had this term minus this one, then there was some constant here, then you would understand that this method is harder. Yeah, it takes longer to work out than using the difference of two squares. I would recommend using the difference of two squares. It will save you time. A new example, starting by squaring both sides. Moving this term to the left hand side, or moving this one to the right, doesn't really make much difference. You have two square terms and you have a difference, so this is the difference of two squares. So add the terms together in the first bracket, so 2x plus 1 add 1 minus 4x. So that 1 and that 1 gives you 2. The 2x plus minus 4x gives you minus 2x. And now subtract the terms. So 2x minus 4x. So 2x plus 4x gives you 6x. 1 minus 1. The ones cancel, so you've got this. And your critical values then for this part to be 0, x is 1. For this to be 0, x equals 0. And then do your sketch. And on the sketch, you either need an n-shaped curve or a u-shaped curve, because this is a quadratic inequality. If you multiply these two terms together to get the x squared term, it will have a negative coefficient. So you need something like this, and then marking the critical values. So that's 0, and that's 1. The region we're looking for is, it says less than or equal to 0, so on the line and below. So this region here, x less than or equal to 0, and this region here, x greater than or equal to 1. Another example, so squaring both sides. And then I've taken this term to the left hand side by subtracting it from both sides, and now comes the difference of two squares. It's a square term, this is a square term, there's the difference. So in the first bracket, add the terms together, so x plus 3x, 4x, 3 plus the 1, 4. And in the second bracket, subtract, so x plus 3 minus the 3x plus 1, 3 minus 1 is 2, x minus 3x gives you minus 2x. So the critical values here will be minus 1 from this part, and from this part 2 minus 2x equals 0. So 2x is equal to 2, x is equal to 1. And now we're going to do the sketch. The 4x times the minus 2x will give you minus 8x squared. So that will be an n-shaped curve, and our critical values there are minus 1 and plus 1. It says greater than 0 here, so the region that we're looking at is above the line. That's a single continuous region, so the solution lies between minus 1 and plus 1, like this. In this inequality, the modulus part here is multiplied by 3. So what you can do is multiply these two terms by 3. So you have 6x minus 3. So now you've got this. And then continue squaring both sides and so on. Just use the previous method.